This is a question from homework section 1.1. Thank you to the student who sent the question. Now, if you're viewing this video and you're not the student who asked about the problem, it's possible that your problem, although it would be very similar, could look slightly different than this one. And by that I mean that the numbers could appear differently. But let's talk through this question. We've got a cylindrical tank. So I'm going to draw a sketch of that so I have a rough idea of what we're dealing with. And the area of this circle is given as 49 centimeters squared. Do you read that from the question? We have a cross-sectional area of 49 centimeters squared. So that means that the area of the base, you could say, is 49 centimeters squared. And we've got water. Oh, let's use blue for the water. That would be a lot more exciting, right? We've got water filling this tank up to, now actually it's going to be even across the top, right? I like to think of it as wavy water, but when we measure it, it's of course going to be even. And what I don't like about this problem is that they use the 49 again. I wish it was a different number so that those two 49s don't get confused. But I'm going to use a blue 49 for this depth of the water. And what do we know about this tank and the water that's contained in it? When we start the clock, so when time equals 0, a drain at the bottom of the tank with an area of 7 centimeters. And let me say that this little drain at the bottom, this is here at the bottom, this little drain at the bottom, it really doesn't matter that that drain is 7 centimeters squared. That 7 centimeters squared is going to have something to do with how fast the water goes out, but we have this nice formula that tells us something about how fast the water is draining. So we don't actually need that piece of information that the opening is 7 centimeters squared. So let's just ignore that 7 for now. The depth of the water in the tank when the time is greater than or equal to 0 can be represented with this function. The depth of the water with respect to time is equal to 7 minus 3 2/10 times the time quantity squared. Calculate and interpret d of 0. I think that the question asker, the student who asked about this, I think already got this part, but just in case anyone's watching this video after. This d of 0 is how we'd read this in function notation. What that means is when t is equal to 0, find the depth, or the depth when time is 0. And we're already given that the depth when time is 0 is 49. So we have this one. The depth at time 0 is 49. And to interpret this value, we could say that the value, this 49, is the depth of the water initially in the tank, or when we start the experiment, or when we start taking time, right? So initially at time 0. And that 0, is, almost always you could think of that as representing initial time, or initial whatever that t or independent variable is in here. And let's look at part B. The tank will be empty at blank seconds. At what time is the tank empty? How can we interpret an empty tank? Empty is going to mean that the depth is 0, right? So another way of asking this question would be, when is d of t equal to 0? Well, d of t, the depth with respect to time, is 0 when 7 minus 3.2t squared is 0. So this part B is asking us to set the function equal to 0. So if d of t is equal to 0, then 7 minus 3.2t quantity squared is 0. So here we have a quadratic equation. We've got it set to 0. It solved the quadratic equation. And what may throw some students off about this is that the first step is actually done for you. Let me rewrite it like this. And maybe this will ring a bell for you and you'll be like, oh, I see now. Oh, I didn't mean to write that. I meant to write 7 times minus 3.2t, right? Let me erase that extra decimal there. So the 7 minus 3.2t squared means 7.32t times 7 minus 3.2t. And so we have a quadratic equation that's already factored. Do you remember the next part, the next step to solving a quadratic equation? What this equation means is that one of the factors, one or both, but at least one of these factors is 0. Now in this case, both factors are the same, so all we have to do is say that one of them, the 7 minus, sorry, I keep wanting to put that decimal in there, 7 minus 3 2/10 t is equal to 0. Let me get rid of some of this other gibberish here so that it's not in the way. Here, let me rewrite that so that you can see it really clearly. The next step would be to say that 0 is equal to one of these two factors. Oh, I am so sorry. It's too early in the morning and I keep putting that decimal there. Okay, so we've got 0 equal to 7 minus 3 2/10 t. Now we're just down to a basic linear equation. So I could subtract 7 from both sides and then divide by negative 3.2t, and I'd get that t is negative 7 over negative 3.2. And when I put that into my calculator, oh, it's already erased. Let me pull it up again. I got 2.1875. Notice that those two negatives divide each other out, so they undo each other. We've got a positive 2.1875. Now be very careful about the fine print, the blue instructions. When you start typing the answer in, this one asks us to type an integer or a decimal that's rounded to the nearest tenth. So we could say that this is approximately 2 2/10, so 2.2. So part B is going to be 2.2. And what's an approximate, or appropriate, I'm sorry, what's an appropriate domain for D? So what can T range from? On a number line, we could see that certainly we can't go below T equals 0. But what's the longest it's going to take before the water in this tank is all gone? So what's the time frame where the draining stops? It's going to stop in 2 2/10 seconds, right? Because at 2.2, the cylinder is empty. So our domain is going to include 0 and go up to 2 2/10, but include the 2 2/10. I hope that this short video helps. Please let me know if you need any further explanation about any part of this question. And thank you again for working on the homework, and thank you for asking the question.